Hey guys, I'm just making a little video on bond angles. I'm gonna talk fast so that this video is short, and also I just want to say this isn't on how to do Lewis structure. This isn't how to guess shape exactly, because I figure since there's a lot more emphasis on us learning that, it's probably a much smaller chance that anyone would need help with that. So I'm just talking about maybe a slightly better way than just pure memorization to know where these angles come from. So to start, for all intents and purposes on our level, I think we can attribute where bond shape and therefore bond angle, molecular structure and therefore bond angle, I think we can attribute it pretty much to electron-electron repulsion. Electrons repel each other. Opposites attract, likes repel. So, how do we find electrons in these Lewis structures? We find them in two places. We find them in the form of bonds. We find them in the form of lone pairs too. So the thing with these bonds is, since the electrons are stretched out between two atoms, they're going to be a lot farther away on average from anything that they might be interacting with than a lone pair, which is just right up against. I've been recording this for a while, so it started out. So the idea is, this guy's closer to whatever he's interacting with, so he's going to be stronger. This guy repels stronger than this guy. So now, this guy's easy, they're just, this section and this section is just going to be repelling from each other as far away from each other as they can. That's a straight line. They're pointing in opposite directions. Straight line, 180 degrees. Not hard. Doubt anyone has trouble with that. Trigonal planar, similar to this guy, except there's three of them. So you divide 360 degrees by 3. You get 120 degrees. And an important thing to note is the reason why it's the same bond angle is because each of these things is exactly the same. So how could this and this, let's say, interact differently than this and this? It has to be exactly the same. These two have to be the exact same angle. Oh, except these two are also exactly the same as this here. So it's all the same angle. You have to divide the maximum, like 360 divided by 3. You get 120. And maybe why is it planar? Why doesn't it, stick out here maybe? Maybe you just got to understand that that if you pull it up, this would make these closer together than they are now. So now I'm going to move on to tetrahedral. I don't think that for these three angles, I don't think you can get around memorizing that these angles are the angles. But what I think you can do, a way I think you can be better, is to, instead just memorizing this goes with this, this goes with this, this goes with this, is to maybe understand why. So if your memory there ever fails, you can, and you just remember that these angles are the angles, you can say, oh, well, that's got to go with that, that's got to, Okay, so now I'm going to start explaining. This guy is 109.5. I think you just got to memorize that. But what you can remember is that this is the biggest of the three, because these have to be smaller, and I'm about to explain why. So look at this ammonia. I think that's ammonia. Ammonium's the one with 4, right? Okay. So imagine this guy is a lot like, ignore these H's for now. This guy is a lot like you just replaced one of these bonds with a lone pair. And what do we know from when we was talking up here? We know lone pairs repel stronger than electron pairs. So these guys are going to get pushed further down. That's what this drawing here was for. It's like saying, look, see here, the drawing is similar to this right here, where it just sticks out to the side. But because this guy here repels stronger, it just pushes these guys down a little bit, and they're just a little bit pointed down. And that's why this is just a little bit less than this, 107. This guy is just like if you took even one more of these guys, these bonds, and replaced it with a lone pair. Just one more of these guys replaced it with a lone pair. And that's why it's a little bit less. They're just pushed a little bit closer together. 104.5. And if you notice, this guy is actually 2.5 degrees closer than this guy, and this guy is actually 2.5 degrees closer than this guy. So I don't know if we can find that pattern everywhere else, but it's at least here, and that's kind of cool. I know these aren't exact, but I don't know. There you go. One more thing I want to talk about is there are two different, they're like, you know, bent is not just with two lone pairs. Bent can be with one lone pair. These are just variables. So what happens when bent is with one lone pair? Well, what you do is you get a situation like this, where it's like, oh, same thing here, except replace just one of these electron-electron bonds with lone pair, push them a little bit closer together, and that's why the information I saw that was designed for our level just says that these one lone pair bent angles are less than 120 degrees. That's what the sources I saw, multiple sources I saw said less than 120 degrees. I think that's what you gotta know. I hope this video hasn't been too long. Have a good day. Hope this helped. I don't know if it did. Have a good day.